So question number 1 says find the product of 126 and 5. What is the meaning of product?
Times.
Times, exactly. So we just need to times 126 with 5. How much is that?
Um,
Yes,
630.
exactly. So the answer is 630. So here the main key thing is to learn is that product means multiplication. Okay. Question number 11. Read it.
Shannon does 15 press ups each day in January. Work out how many press ups Shannon does in January.
Yes. So how many days?
15 times 31.
Exactly. There are 31 days in January, so we need to times it with 15 to find total press ups. So let's do it together. Yeah, so the answer is
165.
400 and
65.
yes, 465 press ups. Very good. Next one, this is a simple division, so we'll just go to the question number 13. Read it.
288 guests attend the wedding. Each table at a wedding will sit 8 guests. How many tables are needed? 288 divided by 8.
Exactly, we need to divide here.
Didn't
And
we already do this?
this one we did, I think. Okay,
Yeah.
so we can go
Yeah,
ahead.
we did.
Actually, this is a whole, like, there are lots of questions. I think some of them we did.
Yeah.
Let's start with, have we done these ones? Addition and subtraction involving negative.
Yeah.
Okay. Inequality sign. This one?
No.
No. So, do you know how to put this? The open side should be towards greater number, right? So just tell me
Mm-hmm.
the last one.
0.5 is greater than 0.39.
Very good. So in decimal, it does not depend on the number of digits like in whole numbers, right?
Mm-hmm.
Hmm. Okay, try this. 51.
um,
So here, see,
mm,
this calculation you need to use to solve it, to solve this and this.
83. And second one is 1469.
Very good. Second one is 14, 6.
No. 14,691.
This only, but there are two zeros which are extra. You can see after 83 and 177, we don't have any zeros, right? But here we have
Oh,
zeros. So when you are multiplying, you need to add these
so
zeros
two
at the,
extra zeros?
yes, two zeros. There would be two zeros at after your answer, right?
Mm-hmm.
Okay, multiples means just you need to write the times table of 3, right? Just tell
Mm-hmm.
me first three multiples of 3.
Uh, 369.
Very good. Now common multiples of 4 and 6.
24. And 12.
Yes. And one
Uh,
more.
uh, uh, 16.
16.
I
But
think.
16 does not appear in 6 times table.
30, 36.
Very good. 36. That's great. Factors. Factor means the number with which 18 is completely divisible. This is what factors of 18 means, with no remainder, right? So can
Mm-hmm.
you give me factors of 18? See,
Um,
the easiest way to figure out factors is like 1 times 18 is 18, right? Then check in 2 times table. 2 times 9 is 18, right? Then check in 3 times table. 3 times 6 is 18. So, and then again, if you check 4, 5, 6, again 6 would repeat, right? This 6. So you don't
yeah.
need to do 6. All these numbers 1, 18, 2, 9, 3, 6 are the factors of 18. Okay,
Mm-hmm.
yeah, that's how we do. When you have to stop when the same number is repeating. So for 40, can you write the same thingy? What should I write? First statement would be
1, 2, and
1
4.
times. Okay, 1 times 40 is 40. Then you check
Mm-hmm.
in 2 times what?
20,
Yes. Does
and
it
4
appear?
times 10.
Exactly. And what about 5? Does it appear in 5 times table?
Yes, 5 times 8, I think.
Okay. Why did it move up? 5 times 8.
Mm-hmm.
Very good. So all these numbers 1, 40, 2, 20, 4, 10, 5 and 8 are the factors of 40. Clear?
Clear.
Yeah. Now let's find the common factors of 16 and 20. So first we need to write the factors of 16 and then 20, and then you need to figure out which factors you can see in both of them. Okay. So first let's write the factors of 16. So 1 times 16 is 16, and 2 times, yeah, 2 times what? Are you there?
Um, yeah,
Okay. Yes, tell me 2 times. What?
8.
Yes. And then does it appear in 3 times table?
No.
So let's check with 4.
4 times 4.
Yes. 5. Does it appear in 5, 6, 7? Yes or no?
Um,
5, 6, 7. It does not.
no.
Yes. What about 8?
8 times 2.
Yes. So again you can see 8 times 2 is repeating, right? So here you can
Mm-hmm.
stop. Only these are the factors. When it is repeating again, like 2 times 8 you already write, but now after 4 it is again coming 8 times 2, which you have already done. So you don't need to write that. So 1, 16, 2, 8 and 4 are the factors of 16, right? Now let's check for 20. So again we start with 1 times 20 is 20, right? 2 times, yes,
10.
yes, is 20. Then does it appear in 3?
No.
What about 4?
Yes.
So 4 times,
Uh, 7.
4 times 5, right?
Oh, yeah, 5.
Hmm. Again, if you write 5 times 4 would go, right, because after 4 it appears in 5 times table, which you already wrote here, right? 4 times 5 or 5 times 4 is same thing, right? We learned this in
Mm-hmm.
that property of multiplication. So factors of 20 are 1, 2, 10, 4, 5, 4, 5 and 20, right? Now let's
Mm-hmm.
see the common ones between them. So 1 is common, so 1 is always there, so we can just ignore it. If you see, can you tell me what are the common numbers that you see in both of them?
So there's 1, 2, and 4.
2 and 4. Okay, very good. So 1, 2 and 4. That's great. Then now let's see how we find LCM. LCM means least common multiple. Okay. So let's say we have to
Okay.
find a LCM of 12 and 15. I will give you another question after this. So we just write 12 and 15 and they both appear in 2 times table. No, sorry, the 15 does not, but one of them does, right? So we can do
Yeah.
with 2, we'll get 6 and 15. They both appear in 3 times table, so 2 and 5. Then we can do again by 2, we get 1 here, and then we can divide it by 5 to get 1 here, right? 5 divided by 5 is 1, and this is already 1. If I times all these numbers, I will get LCM. Okay,
Mm-hmm.
so 2 times 3 times 2 times 5. 3 times 2 is 6, and 5 times 2 is 10. 6 times 10 is 60. So the answer is 60. Clear?
Fair.
Yeah. But to find the highest common factor, what you can do is, for example, here we have 18 and 45. So we can divide both of them with, I think, 3. 3 times 6 is 18. And here 45, if you divide by 3, 3 times 1 is 3. 1 you can just give to 5, it will become 15. 3 times 5 is 15. So here you got 15, right? Again you divide
Mm-hmm.
by 3, so you get 2 and 5. Then you, because they both are prime numbers, you need to check over here. If they both are prime number, you can just stop it, stop doing it any further, and that is going to be your answer. Okay, which is 3 times 3, which is 9. Okay,
Okay.
yeah, is that clear? So the
Yes.
very good. So only difference between like the way we are finding LCM and HCF is that in LCM we need to solve it until we get 1 1, right? And then times all these numbers like we did here, right? But in HCF, highest common
Yeah.
factor, we need to just like we don't need to get 1 1 here. These numbers should be prime numbers. Okay, and here we can stop and just
Okay.
multiply these numbers like this. Okay, so what is prime number?
Uh-huh.
What is a prime number?
Oh, we did that.
This one we did. Okay, can you
Mm,
just define what is
yeah.
prime number?
Prime numbers are numbers that only have hmm, one and the number itself.
Yes, it has only two factor, one and the number itself. And what are composite numbers?
Hmm?
Composite numbers, they have more than two factors. Okay, for example,
Okay.
15, its factor is 1, 5, 3 and 15, right? So it has
Yeah.
more than two factor. Numbers which have more than two factors are called composite factors. Next is square number. Squaring a number means multiplying it with itself. For example, 6 square is 6 times 6, which is 36. So 36 is called a square number because we are getting it by multiplying a number with itself. Okay, so 36 is a square number.
Okay.
Is 10 a square number? No, because 10 is 5 times 2, not um, here we are not multiplying a number with itself. Okay. Can you calculate this
Mm-hmm.
37 square?
Um,
Yeah, what's your answer?
1010?
No. See,
Huh?
that's how you times 7 times 7, 49. 9 here I wrote, 4 is there. 7 times 3, 21 plus 2, 25. Then I wrote a 0 there. 3 times 7, I did 21. Then 3 times 3, 9 plus 2, 11. Then I added them. 9, 5 plus 1, 6, 2 plus 1, 3, 1. I just added them. Right? So that's my answer, 1369. Okay? I think you made some calculation mistake. Can you check that? Do you get it?
Okay. Oh, yeah.
Good. Like when we do a square of any number which is having 0, so you can just square, for example 20 square, so just square 2. 2 square is 4. Oh, sorry. Yeah, so just 2 square is 4 and 0 square means write 0 two times. So the answer is going to be 400, okay?
Okay.
Good. Square root of 81. So to find square root of any number, you can just do prime
9?
factorization. Yes, exactly. 9 times 9 is 81. So 9 is the answer. But let's try this one because you already know this one. So 1225. So because it has 5 at the end, so that means we can divide it by 5, right? We need to do prime factorization.
Mm-hmm.
Only we need to divide by prime numbers. Okay. So I start with 5. 5 divided by 12, 5 times 2 is 10, right? And I give 2 to this number, this will become 22. 5 times 4 is 20. Then we give 2 to this, right? This becomes 25. 5 times 5 is 25, right?
Yeah.
So then we divide this 245 again by 5 because we have 5 at the end. 5 times 4 is 20. Then we give 4 to this. 5 times 9 is 45, right?
Mm-hmm.
Then 49 is 7 times 7, 49. Then 7 times 1 is 7, right? So we need to do it until we get 1 at the end. Now we need to make group of 2. One group of 5, group of 2 same numbers, and then 7, right? So for each group, you need to write that number one time, like 5 one time, 7 one time. We get 5 and 7, just times them. 7 times 5, which is 35. So that's our answer. Clear?
Mm-hmm.
Very good. Okay, cube number means when we write a number 3 times, for example, 2 times 2 times 2, which is 8. So 8 is a cube number. So 100 is a cube number. This is what it is asking. Or 64 is a cube number. So 100 is a square number because 10 times 10 is 100, right? But not
Yeah.
cube. For 61 and 64, if you check it, like if you divide 6, how do we check if 64 is a cube number? Because if it's not necessary that we will remember all the cube number, we can remember some of them. But so to check, you can just again do prime factorization. Divided by 2, what would you get? 3 and 2. Again by 2, 1 and 6. Then again by 2, you get 8. You get 4, then you get 2, then you get 1, right? Then we make pair
Mhm.
of 3. So here we make a pair of group of 3, sorry. This and here we got one more group of 3, which are same numbers. So we got two from here, this group, and one from this group, right? If we times these two, we will times it. We got 4. So 4 is the cube number. Like if we cube 4, we will get 64. This is what it mean, right? So yes, it is a cube number. Okay.
Okay.
Yeah, that's how we check. Suppose the question give us, and that's how we write cube root. Find cube root of 64. How would you find? Do the same method, okay? And that's how you got cube root of 64 is 4. Okay?
Okay.
Yeah. Can you try find a cube root of 27? No, let's do, yeah, okay, first do 27.
uh, 4 times 7 is 27.
4 times what?
Nothing. Um, um, 3.
Yes, it's 3. Even you can check it. 27 you divide by 3. 9 you get, right? Again you divide 9 by 3, you get 3. 3 divided by 3 is 1. So you get a group of 3, right? That's how we got
Mhm.
3. Okay, can you try this? 8,000?
Okay.
Yeah.
Um, is it 20?
20, very good. That's correct. Yes, that's 20, okay? If you divide this by
Okay.
20, um, you can see you get 400. Again, you divide 400 by 20. So you get 20, right? And you divide 20 by 20, which is 1. So we have a group of 20. A group of 3 numbers, which is the answer, okay?
Mhm.
Indices is also called exponent or power, like 2 to the power 4. This is indices or exponent. This is called base. That means 2 is multiplied 4 times. Indices is used when we are multiplying a same number multiple times. So this is just a short form. So we can write 2 4 times. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So that's our answer. Clear?
Clear.
Try this. 9 to the power 4. 9 to the power 4 means we need to multiply 9 4 times. So we do 9 times 9, which is 81. And then 81 times 9, which is 729. And again we do 729 times 9, which is 6561. So that's our answer. Okay.
6,561.
Absolutely correct. Okay, can you write this in index form? Like in this form?
Mm-hmm. 6 to the power of 5.
Very good. 6 is multiplied 5 times, so the power is going to be 5. Okay, great. Let's write this in the form of 2 to the power n. Yeah.
Huh?
See, you have two numbers, two exponents. You need to multiply them. They both have same base. They both have 2 and 2, right? So when they are in
Yeah,
multiplication, we just add the power. 3 plus 5, which is 8. So the answer is 2 to the power 8. Clear? In division, what you
yeah,
need to do, we need to subtract them. Like here we are dividing them, so we subtract 10 minus 2, okay, which is 8. 5 to the power 8. Clear?
clear.
Very good. When we have two power like that, we just need to multiply them. So this will become 10 to the power 6 times 2, which is 10 to the power 12. Okay,
Okay.
good. Negative indices, it will convert into positive if you write 1 in the numerator. 1 over 5 raised to power 2. Can you try this one? The same way we did this.
um,
Yeah, you need to do same thing what we did here. It's same.
uh, uh, 0.5
No, this way.
over
Just write 1 in the numerator and like we did this one.
um, 1/10
1 over 10
and
raised to power
3.
positive 3. Yes. Okay. Tell me this 1 over 5 raised to power 2. Okay. 3, let's say. So this in negative power will become like this, right? If we remove 1 from the numerator, the power will become negative. So write 20 as a product of prime. So basically, and write your answer in index form. So what you need to do, 20 as a prime means you need to do prime factorization. Because 20 is even number, so we divide by 2. If we divide by 2, we get 10. Again we divide by 2, we get 5. Again we divide by 5. 5 times like 5 divided by 5 is 1. So we need to divide until we get 1 here, okay? So can you tell me this in the index
Yeah,
form? This in the index form, 2
um,
2 times 2 is
2 times 2 is 4.
no in index form. These
Uh,
are the product of the prime numbers, right? We just multiply all these number. These are all prime numbers. You can see 2 and 5. Index form means what? Power form, 2 square, because there are 2 times 2, right? 2 square times 5. Clear?
yeah,
Okay, try this. 85. I mean, sorry, 48, not 85. Yeah, try it. So how do we do it? We
okay.
can divide it by 2 because we have 8, which is even number. We need to just check one's digit. If it is even, we can divide by 2. So we get 2 and 4 here. Then again we divide 24 by 2. We get 1, 2 divided by 2, 1, 4 divided by 2, 2. Again we divide it by 2, we get 6. We divide this by 3, we get 2, and this again we get 2 divided by 2. We need to divide until we get 1. 48 as a product of prime number 1, 2, 3, 4. So we can write 2 to the power 4 because we have 4, 2. And then we can write 3. And that's our answer, right? Yeah, did you get your answer?
Yes,
What is that?
2 to the power of 4 times 3.
Very good. That's correct. In this one, you need to check what is the number. This prime product is given, product of prime numbers. Okay. Basically, you need to expand. Can you try it?
Hmm?
Yeah. You want to try it?
No.
Okay, let me explain. 2 square means we need to multiply 2 2 times. 3 square means 3 times 3. Then we have 5. So 2 times 2 is 4. 3 times 3 is 9. And then we have 5, right? Then we multiply this. 9 times 5, we can do either way. It will work. Let's do 4 times 9 first, which is 36. And then we have 5. So 36 times 5. If we just do this, 36 times 5, 6 times 5, 30, 5 times 3, 15, plus 3, 18. So we got 180. That's our number. Clear?
Mm-hmm.
Very good. Um, find the HCF and LCM of 48 and 60. So we have two numbers, and for both of them, we need to find LCM and HCF. Okay?
Mm-hmm.
Yeah. So you can try it. Okay?
Okay.
Hmm. So to find LCM, we need to just take 48 and 60 together. Here I am finding LCM. So they both are even numbers, so we can start with 2. So we got 24 there and 30 there. Then again we divide by 2, we get 12 here, and this is going to give me 15, right? 30 divided by 2. Again, I'm dividing by 3. So this is 4 and this is 5, right? 12 divided by 3 and 15 divided by 3. Then I'm dividing by 2. I got 2 and 5. Then I'm dividing by 2 again. I need to get 1 here. And here I have 5, right? So I need to divide by 5 to get 1, 1, right? 5 divided by 5, that's how I got 1. So I need to multiply all these numbers to get my LCM. So let's just multiply it. Basically, what we have here is, um, first we do 2 times 2, which is 4. Then we do 4 times 3, which is 12. And then 12 times 2, 24. Then 24 times 2, which is 48. Then 48 times 5. So that's how we got 240. This is the LCM. To find HCF, we don't need to get 1 1 at the end.
HDF is 12 and LCM is 240.
Very good. That's great. So for HCF, just do the same thing, but you can stop here. You can stop here. So just multiply these numbers to get HCF. Because we have to stop when we get prime numbers. Here we have prime numbers. Um, okay, next question is standard form. Standard form means we need to write it as the power of 10. Okay, so
Mm-hmm.
power of 10 means like, for example, basically what we need to write, first we need to write a non-zero number and 10 to the power something would come. Okay, suppose a is a non-zero number and n is some exponent. So here non-zero number is 7, right? this number
Yeah.
this number should be less than 10. Okay, one digit number we need to write always. So 7 is less than 10, so I can write it. Then times it with 10 to the power. Now I need to check how many zeros are there. 1, 2, 3, 4, 5. So I can write 10 to the power 5, right? This is called standard
Mm-hmm.
form. Suppose I have let's say I have 19,0,0,0,0. Okay, so how I will write it? I will do um, because 19 is bigger than 10, right? As I said, this non-zero number should be less than 10. So I will write 1.9 times. Now after 9, I need to count
Mm-hmm.
1, 2, 3, 4, 5. 5. So I will do 10 to the power 5. Okay, that's how we do it.
Okay.
Yeah. So let's do number 91. So we need to write this in standard form. Can you try it? So to check
Okay.
this one, as I said, the first number should be this number, or this number, as you can see, is less than 10. So it should be less than 10. So 28 is bigger than 10, right? So what we do is we need to make it less than 10. So we need to put decimal here. That's how we can make it less than 10, right? After first digit. So this will become 2.8 times after a decimal. If you like, if I'm putting decimal here, 1, 2, 3, 4. Count the number of digit after decimal. That's 4. So it will become 2.8 10 to the power 4. Okay. So yeah. Are you done?
Yeah.
Okay. Give me a
2.8 times 10 to the power of 4.
absolutely correct. That's great. Now, if you check this one, because all standard form is used when we need to express a very big number or small. So here these two numbers were large numbers, right? But 92 question, if you see, the number is really small, right? 0.094, right? So to express small numbers, what we do, we write power in the negative. So first digit should be non-zero and less than 10. So I will write 9.4, right? This 94 is bigger than 10, right? So I can't write it. So just to make it smaller than 10, if you have any non-zero number which has more than one digit, so just put decimal after first digit to make it smaller than 10. Then 10 to the power after, um, actually what you need to do, you need to count because you put decimal here, right? So between this and this, you need to count 1 and 2. So there are two digits, right? So this will become 10 to the power negative 2. Clear?
Mm-hmm.
Yeah. For example, if you have 0.00034, so what you will do here is you will write 3.4 times 10 to the power, because I put decimal here, just count 1, 2, 3, 4. 10 to the power negative 4. Clear? Why I am putting negative? Because this number is smaller, right?
Mm-hmm.
Next, this is standard form. These are standard form. But this number is given in the standard form. We need to convert it into ordinary number. So 1.7 10 to the power 4. So first we write 17. Then decimal, we need to move it because the power is 4, which is a positive 4. So we need to move towards right. 1, 2, 3, 4. Okay, 4 places because the power is 4. Now you can see how many blank spaces are there. 3. So put 3 zeros. So the answer is 17,000. Clear?
Mm-hmm.
Okay. Um, can you try this? 2.3 times 10 to the power 3. Try this in the ordinary number.
Okay.
Yeah, so how do we do it? Just write 23 and move the
2.3.
decimal towards 3. Yeah, that's 2.3.
Okay.
So just write 23 and move the decimal by 3 places. 1, 2, 3. And then put the empty places with, like, put 0 in the empty places.
22,300.
Okay, first we write 23, then we move the from decimal 3 place. 1, 2, 3. Yeah, 2300. Very good. Next one is, we have a negative exponent here, right? 10 to the power negative 3. You can see. So first we write 92. We need to remove the decimal, right? From this number, because the exponent is negative. Here the exponent was positive. That's why we were moving towards right side. You can see in all of them I'm moving towards right side from here to here, right? But when exponent
Mm-hmm.
is negative, we move towards left like this. So this is negative 3. So move the decimal. We have decimal here. So move 3 places. 1, 2 and 3. Fill these with zeros. Here we got decimal. The numbers start with decimal. So put the 0 in the starting. So answer is 0.0092. Okay. So when the power is negative, move towards left. When power is positive, move towards right. Clear?
Clear.
Very good. This one in standard form. What is wrong here is basically, as you can see, 450. As I said, this number should be, the non-zero number should be less than 10, right? 450
Yeah.
is more than 10. So that's why it's not correct. So how can we make it less than 10? We can make it 4.5. Okay. Now I'm
Mm-hmm.
putting 4.5 here. So I'm putting decimal, and after decimal I have 2 digit. So um, if I have 2 digit after decimal, so what I will do, whatever exponent is there, I need to subtract 2 from it. So this will become 4.5 times 10 to the power 3. Okay. Oh,
Okay.
sorry, I subtracted by mistake. I need to add 2 digit. So which
Mm-hmm.
will become 7. Obviously, I'm making it smaller, so I need to add. Remember, when we are making this number smaller, like 4.5 is smaller than 450, so we need to add here. Like
Okay.
if we have 260 times 10 to the power 6. So to convert in standard form, 260 we will make it less than 10, which is 2.6, and then 10 to the power 6 is already there. I'm putting decimal here. So after decimal there are 2 digits. So add 2. So 2.6 times 10 to the power 6, 7, 8. And that's our answer. Okay.
Okay.
Yeah. Now let's see how we work out this. How do we add standard form? Okay. So they
Okay.
both have a different power of 10. One has 5 and other has 6. So first step is to make the power of the 10 same. These two should be same. How do we do this? First, as you can see, this is 1.9. If instead of 1.9 I write 19, so I'm making 1.9 bigger. So I can subtract here 1. So this will become 6 minus 5, means 6 minus 1, 5. And this is 3.8 times 10 to the power 5. So they both have same power now, same power of 10. Now what we do is we can just take 10 to the power 5 common from both of them. If we take 10 to the power 5 common, we have 3.8 and 19 this side, right? Just take it outside and add
Yeah.
these two because there is a addition sign. So if you just add them, 19 plus 3 is 22.8 times 10 to the power 5. That's your answer. Okay. But still, this
Mm-hmm.
is not in standard form. Why? 22.8 is greater than 10. 22 is greater than 10. Let's make it smaller. How do we make it smaller? By putting the decimal, right? So I can write it as 2.28. I'm moving the decimal by one place. So I will add 1 here in the power 5 plus 1, which will give me 6, and that's my answer. Clear?
Clear.
Very good. That's how we add. And now to let's check the multiplication. Okay. So the multiplication, for multiplication, we need to just group the numerical coefficients and power of 10. Like this, these numbers times them. 6 times 4 is 24. Then remember 10 to the power 3 times 10 to the power 5. This in law power, what did we learn? How do we multiply it? Can you explain this? Yes, quickly. How do we do this? We learn the
um,
okay.
10 to the power 8.
Exactly, just add the power. So that's our answer. Okay, but we need to
Mhm,
make it into standard form. This is greater than 10, so make it less than 10 by putting a decimal. 24 becomes 2.4 times, because we are making smaller, so we need to add 1 here. 8 plus 1 is 9, so that's our answer. Clear?
mhm.
Okay, let's
Clear.
do this one, then we can have a quick break. Okay,
Okay.
yeah. So to divide, again just divide the non-zero number 4 and 5. So just divide 4 with 5, and 10 to the power 9 divided by 10 to the power negative 2. When we divide, we subtract power. 9 minus negative 2. When we have two negatives, we need to convert it into single. So 2 negative gives you a positive sign. 9 plus 2, which is 11. So here we got 10 to the power 11, right?
Yeah.
And 4 divided by 5, if you just divide like this, because this is smaller than 5, we can't divide it without putting a decimal. We put the decimal there and a 0. And then 5 times 8 is 40, right? And then remainder
Yeah.
is 0. So the answer is 0.8 times 10 to the power 11. To convert it into standard form, this number before decimal, it should be less than 10 but greater than 1. 0 is not greater than 1, so we make it 8.0. And here this, because we are increasing this, so we need to decrease this to make a balance. So 11 minus 1 is 10, and that's our answer. Is that clear?
Yes.